Alright, so welcome back to Intro to AI. In the previous video, we learned about the structure of agents. In this fifth video of the series, we will discuss the structure of goals and tasks that agent perform to solve a problem. So let's get started on that. Okay, so goal trees. We know what goals are, but goals are often divided as sub-goals and represented as trees. Let me show you what I mean. So first we have a goal formulation. Goals help organize behavior by limiting the objectives that an agent is trying to achieve and hence the actions it needs to coincide. Goal formulation based on current situation and the agent's performance measure is the first step in problem solving. And problem formulation is the process of deciding what actions and states to consider given a goal. And goal tree is basically a pathway to the full goal, as we will see in the upcoming part of the video. And there are multiple ways of achieving the subtasks. Just like a navigation for a place, you can take many different routes to each reach your destination. So the choice is up to you. Similarly, which subtask or pathways to take to achieve the complete task of the problem. Let's take a look at how we break down a problem into sort of a tree. Let's say that the goal of an agent was to drive from point A to point B. We can refer to that example we discussed earlier about the autonomous vehicle. And so if you look at the pathway of the problem in the figure, you can see that there are few steps involved. The actions our agent can perform are either move forward or backwards or turn left or right. And so of course the subtasks would include first of all going to move forward, then turn left and then turn right. And the conditions for completing the subtasks can be like no obstacle. There should be no signal or light should be green and whatnot. So forming a goal is quite simple, as we can see. A goal can be anything like we just saw, move from point A to point B. But to achieve that goal, we have to solve or complete the subtasks. And that is basically solving problems on our way there. So let's take a look at how a problem is formulated. We can sort of define a problem by using these 5 components. The initial state, description of possible actions, description for what each action does, the goal test which determines if a given state is a goal state, and the path cost functions that assign a numeric cost to its path. For now, let's just take a note of these components for problem formulation. Let's study what each component is by using an example. So let's say we have an example where our autonomous vehicle wants to go from area of Arad. It's an area in Romania, and our car wants to go to Bucharest, that is another town in Romania. So right off the bat we can see that the first component of problem formulation, which is the initial state, is Arad. The initial state of agent is in Arad. Also, this is the sort of a function that we have created that basically sets the state of the agent as whatever we want. Remember when we talked about internal state? So this is just sort of a reference to a computer programming, or we can just say that agent program that sets the internal state of agent as whatever we give to the function. So let's set the initial state of the agent as in Arad. Next up, we have the actions that can be executed in the current state. So we can say given a particular state S, action S returns the set of possible actions that can be executed in state S. So for example, from in Arad, the applicable actions are go to Sibiu, go to Timișoara, go to Zering. These are the actions that can be performed from that particular state of being in the place of Arad. So looking at the diagram, you can see that you can't move from Arad to Lugoj directly. So the possible actions at that state are only going to Sibiu, Timișoara or Zering, nowhere else. Next up, we have the transition model. As we mentioned before, it's the description of each action and what each action does. Okay, so far we have seen that in this system there can be states and there can be some action that can be performed on any of these states. And so if you take a look at the transition model, it is specified by a function called result SA, where S is the current state and A is the action that is performed on that state. And what the return function results is, it returns the state that results from doing action A in state S. So if we apply that function, for example, result of state of being in Arad, and then perform the action of going to Zering, it results in the state which can be described as in Zering, implying that the agent is in the state of being in the Zering area. And the fourth component of the problem formulation is the goal test, which is basically determines if a given agent is a goal state. And in our case, if you think about it, the goal state is in Bucharest area. So because that was our goal to go there. So that's sort of the function of an agent that tell it that it has achieved its goal, which was go to Bucharest. And then we have the path cost, the final component of the problem formulation. This is also a function of agent program that assigns a numeric cost to each path. In our example, this cost can be the length or distance in kilometers between each destination. So by making all these functions, we have sort of made the entire program or a pathway for an agent to solve through and achieve its goal. So this video was a little bit about the problem formulation. In the next video, we will take a look at the problem solving through search, and we will solve this problem. Soon enough, however, it will get clearer and clearer how the concept of AI is formed and structured. And with that being said, I will see you in the next video.